Hello everyone. I welcome you all to the 32nd lecture of this course, Fundamentals of Building Construction. In today's lecture, we are going to discuss about various machinery and equipment used in construction. So, let us look into the outline of today's presentation. Today, we will be discussing compaction equipment and concrete production equipments. And as in the previous lecture, we have already discussed the earthwork equipments and the material handling equipments. Now, the advantages of utilizing construction equipments, tools and machinery in civil engineering. This is going to be one of the major topics of discussion in today's lecture. So starting out with compaction equipment. Compaction involves artificially densifying soil by pressing soil particles closely together, which expels air from the soil mass. This reduces the spaces between particles, increasing density and stability under load. The goal of this process is to enhance the strength of an earth fill or embankment. The choice of compaction equipment varies depending on the material being compacted. Now, the compaction of soil before starting any work is important so as to increase the stability of the structure. Compactors are designed to utilize one or a combination of the following compactive methods. Static weight or pressure. So static weight, it just applies constant weight on the soil or continuous pressure and loading. Kneading action or manipulation. Impact or sharp blows, and vibration or shaking. These are the few ways in which we can increase the density and compaction of soil. Now, we will discuss some compacting equipment that include smooth wheel rollers, pneumatic tired rollers, sheep's foot rollers, and vibrating rollers. Starting with the smooth wheeled rollers. The smooth wheel roller generates three compactive forces: pressure, impact, and vibration. These rollers are more effective for compacting granular soils like sand, gravel, and crushed stone. The contact pressure generated varies between 310 to 380 kilonewton per meter square. These machines can be either self-propelled or towed, featuring smooth steel roll surfaces. Self-propelled models often have a three-roll tricycle configuration, with the front wheel used for steering and the rear wheels providing the driving power. The contact area between the drum and the soil is a narrow strip, causing soil stresses to diminish quickly with increasing depth. Consequently, this type of roller is best suited for compacting relatively thin layers, typically ranging from 10 to 30 centimeters, depending on the size of the equipment. The drum has a minimal penetration into the soil. When compacting cohesive soils, these rollers often create a crust on the surface, which can hinder proper compaction in the lower parts of the layer. Second, pneumatic tired rollers. These rollers use kneading action to compact soil below the surface. They come in small or large tired configurations and are available as single axle or double axle machines. These types of machines rely on dead weight acting or upon pneumatic tired wheels to produce the compacting effort. Small tired rollers feature two tandem axles with 4 to 9 tires per axle and can be either self-propelled or towed by a tractor. The rear wheels are spaced to cover the areas between the front wheels, ensuring full surface coverage. The tires may be arranged to create a wobbly wheel effect, enhancing the kneading action of the soil. Large tired rollers range from 13.6 to 180 tons in gross weight and have 2 or 4 large earth moving tires on a single axle. The tire pressure can vary from 559 to 1030 kilonewton per meter square. Due to their heavy loads and high tire pressure, these rollers can compact various soil types to greater depths and are often used to proof roll subgrades and bases of earth fill dams. Now, coming to the sheep foot rollers. Sheep foot rollers have cylindrical drums with protruding feet that create high contact pressure areas. These feet come in various shapes such as taper foot or club foot. Due to their small contact area, sheep's foot rollers require many passes to cover an area fully. These rollers are particularly effective for cohesive soils. Sheep's foot rollers are slow, have high rolling resistance, and incur high costs per unit volume compacted. Sheep's foot rollers are effective for compacting clay and sand clay mixtures but are unsuitable for granular soils like sand and gravel. The compacted soil layer depth is limited to the length of the feet. The contact pressure generated varies from 1400 to 7000 kilonewton per meter square. Next, we move on to vibrating rollers. Vibratory compactors improve on static weight machines by introducing dynamic forces, typically achieved through a rotating eccentrically weighted shaft inside the roller. Certain types of soil such as sand, gravel and relatively large stones respond quite well to compaction produced by a combination of pressure and vibration. Vibration causes soil particles to shift and settle more closely together, increasing the density of the mass. Generally, better compaction efficiency and cost effectiveness are achieved by operating vibrating compactors at slower speeds, typically between 2.4 to 4 km per hour. Slow speeds allow more vibratory energy to be transmitted into the soil. Now we move on to concreting equipments. The process of concreting encompasses several stages, including batching, mixing, transporting, placing, compacting, and curing. Each stage requires specific equipment to ensure that the concrete is prepared and applied effectively and efficiently. Now, we will discuss various equipments used in concreting work, which include a concrete mixer, concrete hauling equipment, concrete vibrators, and truck concrete pumps. Starting with concrete mixers. The primary component of a concrete mixer is a drum in which the ingredients are thoroughly mixed by the mechanical rotation of the drum. The mixing process should continue until the materials are uniformly distributed and the mixture has a consistent color and texture. However, the mixing should not be done for less than 2 minutes. Concrete mixtures are generally classified into two types: batch mixers and continuous mixers. Batch mixers. Batch mixers are used for projects of relatively small scale. These mixers can be further divided into two subtypes: the tilting drum mixer and the closed drum mixer. The tilting drum mixer, the drum rotates around a Trunnion axis and can be easily tilted for emptying the mix. This design allows the drum to be rotated and tilted both when it is full and empty. Closed drum mixers. In these mixers, the drum rotates continuously in one direction. The mix is emptied through a hopper that tilts to receive the discharge. Now, moving on to the second type of mixers, continuous mixers. Continuous mixers are employed for large-scale concreting projects where a steady and uninterrupted supply of concrete is required. These mixers operate by continuously feeding, mixing and emptying the concrete, ensuring a continuous and constant supply of freshly mixed concrete without any breaks. Each type of mixer is selected based on the specific requirements of the construction project, ensuring that the concrete is mixed efficiently and consistently to meet the desired standards. Moving on to the concrete hauling equipment. Concrete hauling equipment is essential for transporting mixed concrete from the mixing site to the placement site. Some common types of concrete hauling equipments include wheelbarrows. Wheelbarrows are often used to transport mixed concrete produced by small capacity mixers. They are suitable for short distances and small projects. To prevent mixed segregation, the transportation path should be smooth and as short as possible. Second, being dumpers. Dumpers can transport mixed concrete from mixers with up to 600-liter capacity. They come in two primary forms and are useful for medium-scale projects offering a more efficient transport method than wheelbarrows. Then the third type being transit mixers or ready-mix concrete mixers. Ready-mix concrete mixers transport mixed concrete from a mixing plant or depot to the construction site. Concrete mixers with various capacities ranging from 3 to up to 10 cubic meter is mounted on the trucks. It has a wide range of applications, especially for mass concreting works like multi-storied buildings, bridge works, etc. The basic function of transit mixer is to maintain the concrete's liquid state through the turning of the drum till the point of delivering at construction site. Third, we move on to concrete vibrators. Concrete vibrators are crucial for compacting concrete to remove any air bubbles and to ensure proper settling, which enhances the strength and durability of the finished concrete. There are three primary types of vibrators used for this purpose: internal vibrators, external vibrators, and surface vibrators. Starting with internal vibrators. It is used in a concrete construction to remove air bubbles and ensure proper compaction of freshly poured concrete. This is the most common type of vibrator being used. It essentially consists of a steel tube having eccentric vibrating element inside, which is connected with a motor through a flexible tube. Diameter of steel tubes vary from 40 mm to 100 mm. Internal vibrator used for vibrating concrete in column, beam, retaining wall, etc. External vibrators. These vibrators are clamped rigidly to the formwork at the predetermined points so that the form and concrete are vibrated. They transmit vibrations to the concrete via the framework. They consume more power for a given compaction effect than internal vibrators. The external vibrators are more often used for precasting of thin in situ sections of such shape and thickness that cannot be compacted by internal vibrators. Thirdly, surface vibrators. These are placed directly on the concrete mass and best suited for compaction of shallow elements and compaction of very dry mixes. The main application of this type of vibrator is in the compaction of small slabs not exceeding 150 mm in thickness and patching and repair work of pavement slabs. Fourth, truck concrete pumps, also known as boom pumps. Truck mounted concrete pumps are used to supply concrete to places which are difficult to reach by other heavy machines. Concrete pumping equipments are concrete pump, heavy duty pipe, hose, and other accessories. When pressure is applied to a column of fresh concrete by the concrete pump, it forces the concrete through a lubricated pipe. Concrete pumping is useful in the areas where space available for construction equipment is limited. It is faster and saves enough manpower and energy. It is all-weather operation and does not require heavy equipments like cranes and hoists for other construction operations. Now, the most commonly used machineries in a construction site. Now we are going to discuss some of the important machineries used in construction work. Vibrator sand screening machine. Sand, before they are put to use, are screened and washed. Screening is essential to remove dirt, dust, and silt from the sand to bring quality in construction. It has the following features. It can sieve both dry as well as wet sand in an effective manner. It avoids sand wastage, and its eccentric shaft creates vibration. Moving on to the sand making machine. Sand is an important constituent for the construction industry. River sand is generally preferred, but sand mining from the riverbed and its transportation is not at all an easy task. Sand making machine fulfills the demand of the construction industry in a substantial manner. The machine consists of feeding hopper, rotopactor, sand screen, conveyors, elevators, electrical prime movers and controls, etc. Rotopactors of varying sizes are used to crush stone from which sand is obtained. The sand so produced is utilized in the construction of buildings, pavements, streets, roads, etc. Moving on to concrete lining paver. It is widely used for pavement of canal, runway roads, flooring, reservoir, bridges, etc. The function of concrete lining paver is to finish the laid concrete in desired thickness and prepare a level finished concrete layer. It consists of a sturdy frame structure made from plates, pipes, and angles. It consists of two hydraulic power pack units. One is at fixed console from where the operator operates the machine, and another is traveling unit, that is undercarriage. Each unit is equipped with electric motor. The complete frame, according to the required length, is mounted on four heavy-duty mechanical jacks, which are used for leveling of the machine. Next, pneumatic gunneting or shotcrete machine. This equipment consists of a twin chamber gun and a twin water tank and is powered by air motor. The material is deposited on the desired surface through a placing nozzle under compressed air. The applications of these machines are as follows. For sand blasting work by fitting on a sand blasting nozzle. For repair work of concrete structures of all kinds, including reinforced concrete and stone floors damaged by fire, weathering, or chemical attack. For repair of cracked walls, piles, or beams of concrete or reinforced concrete structures and masonry. For production of thin walled structures like walls, dams, shells in conjunction with steel fiber or mesh wire. For production of watertight plaster for vessels, tunnels, dams, etc. And finally, for repair of foundations and load-bearing elements, repair of bridge sections, fireproofing of iron structures, consolidation and extension work in mining tunnels, etc. Moving on to plastering machine. It is particularly designed for the building and construction industry to improve work efficiency and effectiveness. The plastering machine provides homogeneity and higher density and consistency of the plastered surface, and in combination with lime, which is a natural insulator, or with plasticizer that provides waterproofing capabilities to the walls. Below are the advantages of using plastering machines. Better quality of plastering, which eliminates leakage, cracking, and peeling off of dried plaster. Reduced on-site labor, reduced material wastage, shorter working time, spray and deliver mixture up to 80 meters. Now, advantages of utilizing construction equipment, tools and machinery in civil engineering. In the field of civil engineering, the use of construction equipment, tools and machinery offers numerous advantages, enhancing the efficiency, safety and quality of construction projects. These benefits include increased efficiency and productivity. The deployment of machinery such as excavators and bulldozers accelerates earth moving operations, while Concrete mixtures ensure consistent and rapid mixing of concrete, significantly reducing the time required for construction activities. Second, being precision and accuracy. These tools help maintain consistent dimensions, alignments, and smooth finishes, ultimately contributing to the overall reliability and durability of the construction. Advanced machinery further enhances precision by automating and refining tasks that require high levels of accuracy. Third, enhanced safety. Utilizing proper equipment and machinery minimizes manual labor, reducing the risk of injuries. Safety harnesses, guardrails, and PPE further protect workers from potential hazards. Quality and consistency. Automated machinery such as welders and concrete vibrators ensure uniformity and high quality workmanship, resulting in structurally sound and aesthetically pleasing constructions. Ultimately, cost effectiveness. Modern equipment with high efficiency engines and fuel management systems lowers the operational cost. Additionally, maintenance scheduling software helps in timely servicing, reducing downtime, and extending the lifespan of machinery. Finally, the environmental benefits. Precision tools and machinery help in accurate measurements and cutting, leading to less material wastage. Modern equipment is designed to be more energy efficient, consuming less fuel and electricity, which helps conserve natural resources. Incorporating advanced construction equipment, tools, and machinery is essential for the successful execution of civil engineering projects, leading to improved project outcomes, safer work environments, and overall efficiency. Now, to conclude the whole session, the effective use of construction tools, machinery, and equipment is critical to enhancing the efficiency, safety, and overall quality of civil engineering projects. Throughout this session, we explored various types of equipment essential in construction, such as compaction tools, concrete production equipment, and other specialized machinery, each serving a unique purpose in different construction phases. Compaction equipment such as smooth wheel rollers, pneumatic tired rollers, sheep foot rollers, and vibrating rollers provide targeted approaches to compact different soil types, improving ground stability and ensuring a firm foundation for construction. The selection of appropriate compaction machinery is crucial to achieving optimal soil density, particularly when dealing with various soil conditions such as granular or cohesive soils. In concrete production, tools like batch and continuous mixers, concrete hauling equipment, and vibrators play pivotal roles in ensuring that the concrete is mixed, transported, placed, and compacted efficiently. The use of truck mounted concrete pumps allows for concrete delivery to otherwise inaccessible areas, improving project versatility and reducing manual labor. Advanced machinery such as sand making machines, concrete lining pavers, and plastering machines further enhance the quality and speed of construction activities. So that brings us to the end of our today's session. I hope it has been very informative for you. Thank you.